systems that we actually manufactured here. It's several times since I've been here. And explain the differences between each of the various platforms. Again, you all know we're Distek, and we're a manufacturer of pharmaceutical products for testing and for dissolution systems. We manufacture equipment for dissolution testing, for product development, quality control, research, development throughout the pharmaceutical industry. We have Distek units in place in every state and in most overseas theaters and countries. Starting in 1976, Gerald Brinker founded Distek Inc. with the thought of providing a better dissolution product to the dissolution testing community. After several early prototypes, the first 2100 dissolution bath was developed in 1985. The system went through several upgrades over the years and is still in use at many locations over 30 years later. I actually know that there's a laboratory over in Philadelphia, Pennsylvania, which is the state next to ours right here. I've walked in there before, and there's about 25 still working 2100s. Not A's, B's, or C's, the original 2100. You've got about 25 of them in this laboratory, and they're still working. They use them every day. 2100 was a workhorse. A lot of places still have them buried in their laboratories and places. A lot of people still use them. They take a look in and keep on ticking. They just keep working. They've been working for years. They have the least amount of electronics on them, so maybe that has something to be said for it. It's a very basic model. It's a motor, an active control that controls the motor, spins it at whatever RPM that you set it for, and if you can throw paddles and shafts on it, and it has a valve that you can control the temperature, it's good to go. That's what everybody wants.
It looks like it could survive the nuclear blast.
Oh yeah. I said we're going to find those on the bottom of the ocean someday, it's still standing upright. Again, any of our Distek field service technicians, validation engineers, or distributors overseas may still see these units in use at laboratories and provide maintenance and validation services on them. As some of you are indicating you are. Not to rest on the success of the 2100, Distek went to work developing other support equipment for dissolution testing as well as new dissolution testing systems. Finalizing a truly new and innovative tester in the mid-1990s brought the debut of the Premier 5100 technician-friendly dissolution tester. This was our first bathless model. It actually has jackets. Oh, I'm sure it's down there.
No, it's okay.
Keeps everybody awake when I keep it cold in here. Again, we came up with our first bathless model. That's the jacketed model, and you see here it resulted in the final improvement here is the 7100. But the very first one we had was the 5100. It offered several different innovative designs to it, not the least of which was the heater jacket that was attached to it. That is patented by our company. That technology, we have the patent on it. Nobody else can manufacture it. Competitors have tried to get around it. Variant actually came out with the type of jacket that was integrated into the glass, but it made it very expensive. They just couldn't get around the jacketed technology that we have the patent on. It meant an end to the leaks, cleaning, and the maintenance. The Model 5100 measures, displays, controls, and prints temperatures in each vessel during the test. Heats media in less than 10 minutes. It brought the availability of having every one of the temperatures was able to be displayed on a printout of each vessel. That was something we didn't have before in the industry. So that's another thing that we developed here at Distek. Having the heated jacket with the availability of heating it within 10 to 15 minutes. They say, I go 10 minutes, it's 10 to 15 minutes is probably more realistic. And the fact that you have RTDs in each one of the shafts, they can actually measure the temperature in each one of the shafts, made it a heck of a lot more robust than previous models. So something that, again, it appealed to a lot of people. There's something about the heater jackets, the jacketed systems, that some customers don't like. I found. I prefer bass myself. It's easier, more controllable, but it doesn't get, if we could come up with our bass, which we're coming out with now also, that the bass systems that have the RTDs in each one of the vessels, can give you a printout of the temperature of each one of the vessels themselves individually. That's a heck of a lot better way to go, but that's what the 5100 first offered. That was the big difference over the 2100 from before. The 2100 was a bath system, and only had the bath temperature itself was controlled. The 5100 offered a jacketed version where each one of the vessels was individually controlled. This in turn led to the upgrade of both of those systems in the mid-2000s to the 6100 and the 6300 dissolution bath systems. The 6100 being the evolution of the bathless format, while the 6300 was an upgraded version of the 2100. Again, not one to sit on our successes. Our engineers went to work, and in 2011, Distek unveiled the third generation of bathless technology, the Symphony 7100. This unit offers the fastest media heating in the industry while empowering the user to conduct up to 3 different unique methods simultaneously. We also released our most current bath platform, which is the Model 2500 system, featuring a brilliant touchscreen with an unparalleled command of the instrument with electronic manuals and extensive reporting and method storage capabilities on board. Those are the 3 models that we currently manufacture and sell here now. 2100 is legacy equipment we no longer manufacture. We still support it with our customers and with our international distributors, but we no longer manufacture it here on site. And 5100 is no longer manufactured on site. That was our first bathless technology type unit. And the 6100, which is the second generation bathless technology, is no longer manufactured. We only offer for sale nowadays the 6300, which is a bath system, the 5100, the 2500, which is a bath unit, and the 7100, which is a bathless. The 6300 is on borrowed time. There's only one reason why we continue to still manufacture the 6300. Because it offers in-vessel temperature readings. And how familiar you are with all of our units, and we'll talk about some of their differences here. But the 6300, each one of these shafts has an RTD in the bottom of it and is able to measure the temperature, and it's a bath unit, but measure each one of the vessels. The 2500 currently, as it's manufactured right now, does not have RTDs in each one of the shafts. We are developing it right now. We're getting ready to debut our next generation of the 2500 that will have RTDs in each one of the positions and will measure each one of the vessels. So we'll have that developed, and then at that point, when that debuts and comes out, we'll no longer manufacture the 6300. So that will become a piece of legacy equipment also. So now we'll be down to the 7100, and the 2500 is the only 2 dissolution platform options from Distek. Going forward, I'm sure we have several things on the drawing board, and going forward from that, we'll be coming out with new equipment later on down the road. We're pretty robust with our engineering department here at Distek. We have a tendency to come out with new products, 2, 3, 4 products a year is what we end up coming out with. Whether it's accessory equipment, whether it's a new bath, there's always things up on the drawing board and things that make the final cut, and we eventually end up coming up with new units. We have a very robust, like I said, robust engineering department here. There's probably 8, along with Jeff Rinker, who's the president. We have about 8 engineers full-time on staff here that are, when I mean engineers, I mean degree engineers, not people in the field engineers. Engineers, mechanical, electrical, engineers that are actually designing the equipment that we're employing in the back there. So it's just, we come up with enough innovative products every year to, we'll be debuting 2 or 3 a year. But again, the 2500 is going to the RTDs in the shaft. It'll have a printout that can print out each one of the temperatures of each one of the vessels, and therefore, once that happens, the 6300 will go by the wayside. The 2100, which you guys are all talking about. So what we're going to be hopefully training you on, I can get my hands on one of these. This was the very first one that we came out with. This actual model right here is the 2100C. The old 2100 and the 2100As and some of the Bs had a flat sit-down type of TCS. And it had different types of configuration for how the tubing hooked up. On this model right here, the 2100C actually had, there's 2 ports on the side of it. This part here came out and went to the bottom of the TCS, and it pumped out the top and went into the top of it right back here. That's how it returned it, and it circulated it around. That's on the C model, and some of the Bs had this type of TCS, the thermal circulator unit. The Bs and the As and even the regular 2100s had a sit-down flat model that was a little bit shorter, didn't have as much robustness within the unit. It was a little bit older, and the pumps didn't last very long on them. But it had to pump into 2 different ways. It had an outlet on this side, an outlet on that side, and a drain in the bottom. I don't know if you've seen those types of models out in the field. Maybe you have, maybe you haven't, but that you may or may not come in contact with something like that with the 2100. I apologize, I don't have a picture of one up there for you, but you get the idea. This basic platform right here hasn't changed over the years, the 2100. It's always been this way, with the bath at the bottom, has the availability of having between 6 to 8 vessels in the bottom of it, depending on what type of model you purchased. As it configured right now, this is a 6-position model. This one's dead-ended right here, and it's got a cap in the center back there, but you could have actually added a spindle back there and made it a 7 model. Those were the popular ones, 6 and 7-position models. Occasionally, a customer would order an 8-position, in which case we would have to take this in the back here, and this changed. There was 2 more added back here, and then 2 more, and it was a different vessel plate and a different head plate that went inside there. And the only other thing that changed about it, basically, other than this all being the same, was the electronics up here changed a little bit. This is the newer one, the last version that came out with 4 buttons on the side there, different buttons to scroll through, the different functions you could program on it, and the RPM, the timing, everything else. But we can go back to where there used to be a rotary knob on the side here to roll up and down. That was all you had for adjusting the RPM. It actually didn't even have an LED readout. It actually had just a number readout that came out. It was a mechanical number device that actually put up a mechanical number up there. So again, we've had different models over the years, and the basic footprint itself has not changed. These are some of the outlines of what the 2100 can and can't do. Again, being our first model, a little old and archaic in the way that it ran, but as you indicated, it did its job. It's been doing its job, so much to the fact that it's probably going to survive a nuclear holocaust. It's got a TCS attached to it. The functions, it has all the functions of all the previous models, being the 2100, 2100A, and 2100B are all present in C. Along with these extras here, it has the availability of doing between 500 and 1,000 milliliters as volumetric in each one of the vessels. RPM control range was 25 to 250 RPM, digitally controlled, closed loop. We can go on with all the other things. Resolution 1 RPM, plus or minus 0.5. The shaft wobble, less than down. These are all the basic numbers that came along with it. But the accuracy of the temperature was able to maintain the temperature plus or minus 0.25. It was a big key to this particular model. It also has on the 2100C had the availability of doing a manual and or an automatic or an external run. You could actually hook up a fiber optic. Well, we had the UV system, fiber optic system, could hook up to it. Some of our software could hook up to it and run from an external platform. You can actually hook it up into the server. We have some customers that have, with our software that we offer here at Distek, to hook it up into their server and control it from an outside entity. They could be at their office and control the bath from their office. Picture of one here. Actually, it's a video. It's a 2100 that's in use. It's only a little 30-second video. The idea from that. We move to the 5100 system. Again, the first bathless technology. Difference between this, no bath. All heater jackets surrounding it. Each one of the positions was individually controlled. You could theoretically, you could set the temperature on each one of these to be different if you wanted to. You have that capability installed in the unit, all controlled from the screen up inside here. This is the first model, again, as I said, for our bathless technology, so the electronic control on it was very archaic, very old, old school. Not a lot of functionality to it, but enough. It was very robust for the amount of time that we had it. Of course, it also had its growing pains. It had some problems with it. It talks about what it can and can't do, but basically the outline of it is that it's a 7 position. You see here, it has 7 built-in positions, volume was from 500 to 1,000 milliliters programmable. Heating time from 20 to 37 degrees was approximately 15 minutes. That was a big change over having a bath unit. You come in off the weekend and turn on your bath, and it would take you a good 45 minutes to heat up from 20 degrees Celsius to 37, so you can start using the bath, where this one here, you could put your media directly in and start heating it. Your RPM control range was from 25 to 300 RPM. Vessel temperature control, each individual vessel is continuously monitored and controlled. Display resolution, the display resolution was 0.01, meaning that it could show down to the 100th of a degree on the display, and the accuracy was plus or minus 0.25 degrees. It has availability of being programmed in manual for individual vessel controls, automatic. It had 30 pre-programmed methods that you could interface into it, and the ports that you could use on it was a RS-232, RS-485, and parallel printers. It had outputs on it, so it could be hooked up to a printer to print out some rather robust reports for its time. But that was our second bath that we came out with after the 2100. That was our first employment of the bathless technology. This gives you an idea what the front of the screen looked like. I don't know if any of you ever seen a 5100. I don't know anywhere that they're really still in use. Most of them have been upgraded to a 6100, if not traded in and a 6100 purchased. The buttons, there was a pattern to how you had to do the buttons in order to use them. There was basically 4 screens that came up on it. There's 4 screens that you could go. You could turn this on, and there's basically 4 screens you could go through on here. Basically by either going sideways to go through each one of the steps, and within each one of those screens you could scroll up and down through 5 or 6 different accessory screens. Each one of them had an individual area to control it, where you had individual vessel control, or an automated, all 7 positions could be controlled at one time. But it's just a rather archaic way of going through and going through the different processes of making it work. A couple of videos of what it looks like. Overhead screen actually showed you RPM from a distance. It toggled through the temperature. It would toggle through like every 3 to 4 seconds, the temperature of each one of the vessels. And if you programmed for a sample time, it would have an audible and a visual indicator up on the screen. It would tell you how much time before the next sample was had to be drawn. It's a little demonstration of how it goes through the different screens. Those all comes from applying the buttons in a certain sequence. That segues us into the 6100. Just basically an upgrade of the 5100 platform, but it actually offered a little bit of a different screen type on the front of it. It didn't have the same kind of interface as far as how you had to get in each one of the screens. It had a little bit more robustness to it. In fact, the same thing as before, it could be offered in a 6 or 7 position platform. Again, it's still heater jacket all the way around, no bath involved. Everything fully detachable, paddle blades, baskets. The big difference with this one, though, was the couple of designs in it. Embedded temperature sensor was in each one of the shaft, permits the precise control of individual heater jackets. Individual vessel temperatures are continuously monitored and controlled. It's the 2nd generation of the patented bathless technology. It allowed rapid heating, media heating from ambient to 37 degrees Celsius in less than 15 minutes. The biggest was the stores and sorts up to 100 different methods by name and creation date. It also records the previous 50 modifications made to each method, noting the user, the date, and the change. So again, we added some more electronics inside of this, and it actually, again, listening to what customers wanted, it allowed us to make a more robust unit for, as far as from control standpoint. Wanted to be able to control and monitor who had accessibility. We actually have user and admin privileges on the unit, so there's a security system on the unit also, which helped a lot of the laboratories be able to control who was running it, what types of methods they were actually allowed to employ, who had the availability of being able to change that, who had the admin rights to do so. So again, a lot of these, again, it was just a natural progression in the mid-2000s of our 5100 to our 6100. And again, that took place with the 6300 also. These are manufactured, same footprint, same basic technology, except the other one was the bathless. This one is the bath system. Basically a merging of the 2100 and the 5100 together to form the 61 and the 6300. It's a bath, we still use it now. Again, it has RTE in each one of these, so it actually can measure each one of the vessel temperatures. The RTE is located at the tip of each one of the shafts. It allows us to, again, monitor the temperature inside each one of them, make changes to the TCS on the fly as needed in order to make the temperature a little bit more stable, less variability to it. Same interface in the screen area, allowed it to run, monitor each one of the temperatures. The only difference between this and the 6100, the 6100 you could program each vessel independently. This one you cannot, obviously, because it's a bath that's controlling the temperature. So you can't control the temperature inside the vessel. You can only control the temperature within the entire bath platform. But again, other than that, it was the same thing as before. It has over 100 different methods that can be created. Past 50 changes to each one of those methods can be controlled, can be printed up by date and by user. Same robustness. Data temperature sensor in each one of them allows continuous temperature monitoring in each vessel and precise control over the thermal circulator. USB compliant detachable paddles and baskets enables rapid conversion between apparatus 1 and 2. Stores 100 methods by name and date to create and allow for rapid system setup, increased throughput, and reduction of errors. The product key technology, it was a key that could actually be pushed into the front of it right here. You put a key inside there and store methods on that key and transfer them from unit to unit. It allowed you to quickly download and transfer the methods between the two instruments. And last but not least, again, stores up to 100 methods by name and creation date. Also records the previous 50 modifications made to each method, noting the user, the date, and the change. The video showing you the screen on this one. Vessel screen where it has an individual readout of each one of the vessels. Visual aid is what the temperature was of each one of them. Also on the screen there, it also shows you the RPM, tells you what mode you're in, manual or automatic. We progressed into 2011, manufacturing the 2500. It's an upgrade of our bath technology. We went from the 2100 to the 6300 to the 2500. And again, as I said before, we're coming out with the newer model of 2500. Right now, all we have control-wise up on the screen here is to show what the temperature of the thermal circulator is. But our new model that's gonna be coming out, is gonna be an electronic version, it's gonna have RTDs on each one of the positions here. It's gonna have tops on it, much like you see on the other. In fact, the one in the back there actually has the covers on the top right now. That's what it's gonna be looking like when it gets done, getting all the electronics added to it. So just instead of having the shafts that come out of it, that's gonna have a top on it, much like any of the other baths that have the RTDs on them, with the wires on the top of it in order to monitor the temperature inside each one of the positions. The 2500, that's what the screen looks like. I don't know how familiar you all are with the 2500 yet. It's a touch screen. It stores a lot of information on there. It actually has the operation manual stored on here. If you go into the settings, touch the settings, and go into the innards of the unit itself, the operation manual is actually stored on the unit. It also has the electronic qualifications are kept on there, so you're able to toggle it and electronically keep track of the qualifications that we do on the units. And it'll actually give an audible and a visual warning as to when the 6 months is coming around and when the units do run out of qualification. It can be toggled on and toggled off. A lot of variability with the new unit, very intuitive touchscreen. It's unparalleled command of the instrument, the electronic manuals, serial numbers, electronic qualification labels, and extensive reporting and method storage capabilities make this a very robust and reliable system. It has the it has the availability going into the settings of setting up the serial numbers of each part of the unit. You can write down each position's vessel, you can write and store it within the unit. You can write down the shaft number, the paddle blade number, the basket adapter, and the basket serial numbers can all be included inside the instrument and printed up for anybody to use it at a later date. So it makes it very robust and very intuitive as far as storing material on board, so you know what unit goes where in each position. It's got intuitive touchscreen color display to maximize the user's productivity and operational control. Programmable thermocirculator, wake up and sleep mode, saves time and conserves energy. It's a hideaway self-priming thermocirculator that improves temperature uniformity and heating time. When hooking it up, there's no priming involved. It's the old 2100 models and even the 6300 models, when you used to have to get some suction going through it, using a tube on it to get it going. You simply hook this up and turn it on, and once you start heating, it primes itself. It'll do so in about 10-15 seconds, it'll prime itself. So there's no priming involved. And on top of it, you can program into the unit, which makes it really good for laboratories, good selling point. You can program to the unit a sleep mode and a wake-up mode. For instance, if they go away on the weekends, most people just turn the unit down. Now when you come into the lab at 9 o'clock in the morning on Monday, or 8:30 or 8 or 7, whenever you come in, you have to turn the unit on and now wait for it to heat up before you can use it, the bath. You can actually program it, much like an alarm clock, to actually come on before you get there. So if you plan on getting into the laboratory at 6 o'clock in the morning, you can program it to kick on at 5 o'clock. By the time you get in, it's heated, ready to go. You can start mixing whatever you're weighing or mixing and get into testing right off the bat. So it's a very, very good selling point of the unit. It's got interchangeable USB compliant paddles and baskets, significantly reduces the transition time between apparatus 1 and 2. Test volume flexibility ranging from 100 milliliters to 4 liters. You have the capability of taking each one of these positions out and putting small volume kits on there, and having 100 milliliter vessels inside there, and very small paddles and basket shafts can be attached to it. That can be added, and we can also go all the way up to a 4-liter conversion kit and actually have a 4-liter vessel in each one of them. We can do 2-liter, we can do 4-liter, and our normal 1-liter, and we can go down to 100 milliliter. So it has a lot of flexibility with the unit. Of course, the 4-liter and the 2-liter bath would have a bigger bath area here. It's a little bit higher, a little bit taller. And with 2 liters, it's the same setup as this right here. We just have longer shafts. But each one of the vessels would be a little bit longer to accommodate a 2-liter. The 4-liter, however, would be staggered. There's one here. It's got a whole different plate here. There's 4 holes. One here, one there, one here, and one back there to accommodate the bigger 4-liter position. But it is a bigger bath and it's a little bit heavier plexiglass that's involved, a little bit more rugged to handle the increased water pressure that's inside each one of them.